let's talk about dilution. I know you know what dilution means, and we always say, oh, let's dilute this, and this is too dilute. So, dilution usually means that, let's say you have a cup that has some, drink in it. If you add a bunch of water, I'm diluting my drink. I probably won't even be able to taste it. Or, if I have ice in here, it's going to melt and dilute my drink. So when do you dilute something? You're adding more solvent, and as we add more solvent, you increase the volume of our solution, and guess what happens to the concentration? The concentration goes down, right? Because if you have, for example, a 2 molar concentration in 1 liter, if you add more water, that concentration will go down as the volume goes up, right? That's what dilution is. But today, we're going to talk about how you can actually measure these levels of dilution. So let's get started with dilution. So this is what dilution looks like. So here you have on the left the most dilute the most dilute solution, right? It has the lowest concentration. On the right, you have the most concentrated solution, right? It's less dilute, more concentrated, right? So concentrated is the opposite of diluted, right? So we dilute things by adding more solvent, but we need to know, in order to calculate the specific dilution, and we do this a lot in the lab. So let's say if I have a beaker that contains concentrated acid, very concentrated, and then I want to make 100 ml of non-concentrated acid. How do I do that? How do I know how much to take from the concentrated acid? This is a common practice in the lab, because I say, hey, I may tell my student like, hey, go and make me a 2 molar hydrochloric acid in a 2 liter flask or something like that. So they will have the volume that they need, they will have the concentration that I want them to do it in, and they will have a concentrated bottle of acid. And they don't know how much. They don't know how much to take, and they have to calculate it. And this is where this comes in. So the formula that I have here, I don't see it, but let me just write it down. The formula that joins both of them is this one. When it comes to dilution, all you need to remember is M1V1 is equal to M2V2. M1V1 equals M2V2. What's M1 and V1? M1 is the first concentration. The concentration you start with times the volume you start with is going to be equal to the concentration you end up with times the volume you end up with. So let's look at, for example, this figure here on the right. So if you start with a concentrated version, let's say you have a 2 molar solution, right? The concentration is the molarity, by the way. That's why we use M. So this, you have a 2 molar solution, and this one is that you dilute it into like 4 molar solution. and you started with 1 liter, and then it's 2 liters. So this one actually, let me go back a little bit. The one with the bigger volume will have a lower concentration. So if you got 2 molar concentration here, let's say this one goes down to 1 molar, because as you go up in volume, you go down in concentration. So let's say we went up in volume by, we started with 2.5 liters, right? Then you end up with 5 liters. So that's what is telling us. That's the rule. When you double the volume, if you double the volume, the concentration will be divided by 2. That's the rule. That's what it means by M1V1 equals M2V2. When you increase the concentration, or no, when you increase the volume, the concentration will decrease by that much. And this is the formula that puts them together. All right. So where does this formula comes from? It comes from the number of moles. So remember that from the previous video, we saw that concentration M is equal to the number of moles over volume. Well, can we solve the number of moles here? Yes, we can. The number of moles is equal to M times volume. The number of moles is M times volume. So here, if we increase the volume, the number of moles stays the same, right? The number of moles is still there. So if you increase the volume and the number of moles is still the same, then M1V1 can be equal to M2V2. So we're saying that the number of moles at the beginning are still equal to the number of moles at the end. But that's just where this comes from. You don't need to know exactly where it comes from. All you need to know is that this is the formula you use. So let's look at an example here. Calculate the molarity of a solution made by diluting this volume and this concentration of a volume of a solution to a volume of 1 liter. So your task here is figuring out which one is M1, which one is M2, which one is V1, which one is V2. So M1 is the one that you started with, 0.1 molar solution. M2 is what they're asking. V1 is the volume that you started with. V2 is the volume of the solution that we want to make. And after you figure out which one is which, you're pretty much done. All you gotta do is use M1V1 equals M2V2, right? So after you have this M1V1 equals M2V2, you have to be able to move out your equation around. So if you have M1V1 is equal to M2V2, now you want to solve for M2. How do you solve for M2? You divide both sides by what's next to M2. So that, hold on, what's next to M2 is V2. So you divide both sides by what's next to M2, which is V2, so that they can cancel here, and M2 is equal to M1 V1 over V2, right? And this will be M1, you have it 0.1 molar, V1, you have it 0.05 liters, over V2, which is 1 liter, we're going to be equal to 0.005 molar, right? So you can see what happens to this, right? We increasing the volume and we decreasing the concentration, right? So this is the second concentration. So dilution is a very common practice in lab, but also it's a very common, question that we like to ask as science teachers. So expect this. And again, the trick is to be able to, from reading the question that you get, to be able to tell which one is M1, which one is M2, which one is V1, which one is V2, and then figure out which one they're asking and which ones that you have. And from there, you can just use the equation to solve for what they're asking. And that's enough for dilution. And again, make sure that you use practice questions provided to you in order to practice this. And I'll see you next time.